So let's take a look at a quick example here. Find the limit as x and y both go to 0 of x squared plus sine squared of y over 2x squared plus y squared. Well, note f of 0, 0 is 0 over 0, which is obviously an issue that we have to work with. So one of the tactics is to, let's see what happens along the x-axis, and then let's see what happens along the y-axis, and then we consider other possibilities as needed. So if I'm first going to take a look at what happens along the x-axis, that means that y is going to be 0. So I'm going to take a look at the limit as x approaches 0 of f of x 0. So I'm letting y equal 0. So this could be equal to the limit as x approaches 0. If y is 0, I have x squared over 2x squared, which is a half. Therefore, along the x-axis, it's going to be a half, or the limit is a half. That's setting y equals to 0. So what happens now if I consider what happens along the y-axis? So what I want is a limit as y goes to 0 of f of 0y, which equals a limit as, y goes to 0. Well, if x is 0, I end up with sine squared of y over y squared. But that equals a limit as y goes to 0 of sine of y over y. Yeah, let's just do that here. Squared. And if you want, you can use L'Hopital's on this, or if you remember this is a special limit, this limit is actually 1. So it's 1 squared, which is 1. Now, the limit from one path along the x-axis is not equal to the limit along the y-axis, a second path. Therefore, I can say that the limit as xy goes to 0, 0 of f of xy, which in this case is just this function, d and e. The limit simply doesn't exist. Now, we may better get a feeling for what's going on with this if we take a quick look at Maple. So here I have Maple set up, ready to go. And with plots, here's my implicit plot. Now, I've already worked on this, so I kind of know what values for x and y and z to put in here. And I realized very quickly that I need to do num points very high. So I put num points at 50,000 to get enough detail. Otherwise, it's just kind of blobby. And here's the graph that I got. Well, let's take a look at this and see what this is saying. Let's make it a little bit bigger. Okay, so what's it mean to make x equal to 0? Well, here's the y-axis. Here's the x-axis right here. This is x-axis coming at us. So think of it this way. If I put the x-axis right at us, now I'm considering what happens to z as y approaches 0. And you can see that it's going toward 1. And there's a gap going on here, but within the limitation of what Maple's able to draw right now, it's getting very close to 1. So convincing that the limit along the y-axis is 1 should not be too hard to do. But what happens when I let y equals 0? So now I'm moving on the x-axis. Well, if I spin this around to the x-axis, let me bring this a little bit better here. So I'm getting some weird angles going on. If I spin around so I see the x-axis, so y is 0, that doesn't tell me anything because what I'm seeing here is this hump from the y. But let's come down here and see what's going on. If I spin this way, what I can see is it's very flat and then comes up. So what's happening is, and I can see it down here, that when y is 0, x is coming to some smaller value. And it's very difficult to picture what it's coming to off of this graph. There's not enough resolution. You know, maybe if I zoom in a little bit more in terms of x and y, I might get a better idea. But clearly, x is going to one thing, and y is going to another. So that kind of supports the idea that the limit doesn't exist. Now, a big hint when you look at graphs like this is sharp turns. And you can see here, get this thing spun around. You can see nice and smooth. Everything's hunky-dory, having a good time. All of a sudden, wham! This really sharp turn down here. That's a big indication that there's an issue, that the limit's not going to exist. How many curves you know are nice and smooth and all of a sudden jump down? The only curves that we commonly use that have that type of behavior or suddenly have a change in direction are absolute values of polynomials. Because as absolute value maybe is coming toward the x-axis, as soon as it hits it, rather than continue on, it sharply comes back up. But typically, this behavior is not seen.